Of course, when we're doing an accuracy assessment of an image classification, we can't visit every single pixel that we've classified and see if we're right. So we need to sample the data. And when we're sampling data, two important considerations is the number of samples that you'll select, and sometimes that's called the sample size. And then also, what sort of pattern will your sampling take? For example, will it be randomly placed or will it be very systematic, every certain distance apart? So the number of observations or the sample size is designed to take a small sample of the population, but that sample is supposed to represent the population as a whole. So when people do sampling for surveys and that sort of thing, that's exactly what they're trying to do. They're trying to get an understanding of the entire population by sampling only a small portion of the population. Part of this depends on the desired confidence interval, how confident you want to be that your results are accurate. We can take observations. We have to talk about how many observations we could take for the entire image, which we'll do first. But then also on top of that, an important consideration is that every one of our classes, after we do our classification or our categories, has to have some samples in it. And it's good to have more than one sample, like 20-some samples at least in every class or category, regardless of whether or not we're taking enough observations to have a true sample of the population as a whole. So one thing we can notice about the sample size, assuming we have a certain standard error that we're comfortable with, a certain confidence, in this case a standard error of 0.5% or a confidence of 95%, what we can see is that as our population grows, our number of samples would also have to grow along this line here, but it flattens out near the end. So that what this is showing us is that whether we have, for example, a population of 1,000 shown here, which would be about 375 samples or so, or 1,000,000 shown here, which would be about 384 samples, the number of samples we have to take to represent that population as a whole does not change by that much. So what we typically do is we go with the high end here, even if it's a smaller population. But if we think about it, if we take a satellite image, it's going to have millions or billions of pixels in it. So this is probably not unreasonable, and it's flattened out completely by here. So oftentimes with a 95% confidence interval, we should take about 384 samples. So this margin of error, this confidence interval, is important. I just showed an example for 5%, right? Or 5% uncertainty or margin of error, and that would require 384 samples. If we only needed a 10% margin of error, we could go down to 96 samples, which is really not that many. But you can see that going in the other direction, it takes a lot more effort. For example, here we're going, we're nearly doubling our confidence by just taking another less than 300 samples. But to do that again, to double our confidence, to get up to 2%, we would have to take about 7 or 8 times as many samples here. So it does get more and more difficult because of the way the margin of error is defined.